So we've got a mass spec for pentane with some of the fragments shown, and we've got to work out which fragmentation equation is the correct one. So let's just recap a couple of basic principles first of all, before addressing the question. So what I always like to do is draw out the molecule in displayed format, so it's just easier to interpret. So pentane tells us that the C double bond O is on the third carbon. So we've got something that looks like this. And fragmentation means to split the molecule into pieces, kind of like jigsaw pieces. And those jigsaw pieces fit together to make the overall molecule. And what we've got to work out is what the size of each one of those jigsaw pieces is. So we have pentane and we have a molecular ion peak, which is 86. So this last peak, called the molecular ion peak, it represents the mass of the whole molecule. So one of the most important peaks there is you can go straight to that last peak and it tells us the mass of the overall molecule if we didn't know that it was pentane. And then we have these two fragments that we've got to work out. So how do we work out these fragments? Well, when you're starting out in this topic, there is a certain degree of trial and error. You just got to break the molecule in places to work out what it is. But a couple of fragments that just keep coming up over and over again across all of the organic questions is 15 and 29. And they always come about from the same thing. So 15 is generated from a CH3 fragment. So 12 plus 3 hydrogens is 15. And then 29 is always an ethyl group. So C2H5. And we can clearly see there's a C2H5 on both sides of the C double bond O. So that there is going to be the one at 29. Right, the 57 one, well, that must be, it must be involving the C double bond O. So 29 plus 12 plus 16 confirms that the 57 one, I just drag a different color for this one, that there, green, must be this bit here. So they are the two fragments that are shown in the spectrum. Now, like I said, this could also produce a 15, a CH3, because there's the CH3 there. So that would be a break there. And that would be somewhere like that. That would be 15 for CH3, but it's not shown. So sometimes you will see spectra where fragments have been deliberately left out, and that's just for simplicity. So let's now look at the question. Which equation represents the process that produces the particle responsible for the peak at MZ57? Well, we just worked it out because we've got a drawing in front of us. It's the CH3, CH2, C double bond O. So I'm looking for that one. Now, one important thing to remember, when writing fragmentation equations, the fragment that is detected has the charge, and then the other part, the other fragment, which is not detected, is a radical. So a radical is a species with an unpaired electron. And that one would not be detected because only charged species are detected in the mass spectroscopy machine. So let's look at the options. We have A, where we're producing CH3, CH2, CO plus C plus dot CH2, CH3. And I actually don't need to go any further. So incidentally, that is the correct answer because we have the plus charge on the radical being detected, and the CH2, CH3 is the radical part which is not detected. But let's eliminate B, C, and D to show that they are not the answer. So for B, there's the fragment that we want, but it has the dot sign, which means it's a radical, so it's not going to be detected, so that's wrong. C, we've got CH3, CH2, CH2, CH2. Well, this doesn't make any sense because that fragment is simply not possible from the molecule because there isn't a carbon chain with 4 in a row. And then we have the bottom one, that fragment is not possible from this molecule, so that's out. So the only correct answer there is this one, which has been perfectly formed from the drawings that I've just done. So to summarize, the last peak is the mass of the overall molecule, called the molecular ion peak. The fragments represent jigsaw pieces that you put together to make up the overall molecule. And finally, when writing fragmentation equations, which are these things, the fragment that is detected has the plus charge, so there, and the bit that is not detected has the dot symbol, which indicates that it's a radical. And of course, the 2 bits on the right must add back to give the starting molecular ion.